students, welcome back to a new mathematics session. In the previous session, we have discussed the basic concepts of inverse trigonometric functions, and we have solved some questions from exercise 2.1. In today's session, we shall discuss the remaining problems from exercise 2.1 and also will discuss few problems from exercise 2.2. Let's move on to the topic. Before starting the session, let's recall the domain and the range or the principal value branches of inverse trigonometric functions. First of all, sin inverse x, domain is closed interval minus 1, 1, range is closed interval minus pi by 2, pi by 2. For cos inverse x, domain is closed interval minus 1, 1, range is closed interval 0, pi. For cosec inverse x, domain is r minus open interval minus 1, 1, range is closed interval minus pi by 2, excluding 0. For sec inverse x, domain is r minus open interval minus 1, 1, range is closed interval 0, pi, excluding pi by 2. For tan inverse x, domain is r and range is open interval minus pi by 2, pi by 2. For cot inverse x, domain is r, range is open interval 0, pi. In the previous class, we have discussed a trick for recalling this range. For that, there is x-axis and y-axis we have to draw, and we have to mark 0, pi by 2, pi and minus pi by 2. And these are divided into 4 quadrants, first, second, third and fourth. And there are some inverse trigonometric functions whose range is coming between minus pi by 2 and pi by 2. So that is sin inverse, cosec inverse, tan inverse, but not exclusively minus pi by 2 plus pi by 2, but minus pi by 2, by using minus pi by 2 and plus pi by 2, these three inverse trigonometric functions we can write. For example, for sin inverse x, it is closed interval minus pi by 2 to pi by 2, and for cosec inverse x, excluding 0 we have to write, and for tan inverse x, open interval minus pi by 2 to pi by 2. Other three inverse trigonometric functions, the range is between 0 and pi. They are cos inverse x, sec inverse x, cot inverse x. But remember, for cos inverse x, closed interval 0, pi. For sec inverse x, we have to exclude pi by 2 from that. And for cot inverse x, open interval 0, pi. There are some other formulas also we have discussed in the last class. That is, sin inverse of minus x is minus sin inverse x. Cosec inverse of minus x is minus cosec inverse x. Tan inverse of minus x is minus tan inverse x. The other three trigonometric ratios like cos inverse, sec inverse and cot inverse x, if minus comes means cos inverse x means pi minus cos inverse x. We have to subtract from pi. And next is sec inverse of minus x is pi minus sec inverse x, and cot inverse of minus x is pi minus cot inverse x. So these are the formulas we have used in the last class, and please recall or memorize these formulas before going for the next slide. Next, let's discuss few more formulas. Properties of inverse trigonometric functions. Sin of sin inverse x is equal to x. Sin of sin inverse x is equal to x. Likewise, cos of cos inverse x is equal to x. Tan of tan inverse x is equal to x. Cosec of cosec inverse x equal to x. Sec of sec inverse x is equal to x. And cot of cot inverse x is equal to x. And next, there is one more set formula, that is just reversing these two. That is, sin inverse of sin x is equal to x. Cos inverse of cos x is equal to x. Tan inverse of tan x is equal to x. Cosec inverse of cosec x is equal to x. Sec inverse of sec x is equal to x. And cot inverse of cot x is equal to x. So these are the formulas we are going to use for today's calculation. And in class 10 we have learned the values of some trigonometric functions. That also let's recall. Like this, 0 degree, 30 degree, 45 degree, 60 degree and 90 degree angles we have learned in class 10. And these values are in degrees, but here in inverse trigonometric functions we will use in radians. So sin 0 degree value is 0, sin 30 degree is 1 by 2, sin 45 is 1 by root 2, sin 60 is root 3 by 2 and sin 90 is 1. So for recalling this one, it is easy to remember like this: 5 values, 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So once you write these 5 values from left to right, another row you have to write the same values from right to left, that is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Once again, just by heart these 5 values, that is 0, 1 by 2, 1 by root 2, root 3 by 2, 1, that you have to write from left to right in the first row, and in the second row the same values you have to write from right to left. The first is sine value and the second one is cos value. These angles also you have to note in order, that is 0, 30, 45, 60 and 90 degree. And if you know sine value and cos values, you can find any trigonometric ratios. For example, tan value calculation, sine by cos we have to do. 0 by 1, that is 0. 1 by 2 by root 3 by 2, that is 1 by root 3. 1 by root 2 by 1 by root 2, that is 1. Root 3 by 2 by 1 by 2, that is root 3. And 1 by 0, division by 0 is not defined. Same way, for writing cosec value, we have to take the reciprocal of sine value. For writing the sec value, we have to take the reciprocal of cos. For writing the cot value, we have to write the reciprocal of tan. So this table either you have to memorize or else we have to recollect it by writing this table in a sheet of paper. Next, let's continue problems from exercise 2.1. Let's begin with question number 11. Find the value of tan inverse 1 plus cos inverse minus 1 by 2 plus sine inverse of minus 1 by 2. In the previous class, we have learned how to calculate the values separately. For example, we know how to calculate the value of tan inverse 1. We used to take y is equal to tan inverse 1 and so on. We will continue the calculation. And this also same thing, and this sine inverse minus 1 by 2 also same process. But here we will go for another method or another approach, and it will be little bit easy and steps also comparatively less. For that, first to take the question tan inverse 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. That is equal to, as we know that here tan inverse 1, there is a positive value here, so it comes as it is, tan inverse 1. But for cos inverse, minus theta means pi minus cos inverse theta. That is what the formula we have learned. So this one we have to change, cos inverse minus 1 by 2 as pi minus cos inverse 1 by 2. And next is sine inverse of minus 1 by 2. Sine inverse of minus theta means minus sine inverse theta. So minus sine inverse of 1 by 2. Once again, go through the question. First tan inverse 1. It comes as it is because there is no negative sign in the angle. And here next is cos inverse of minus 1 by 2. Cos inverse of minus theta is pi minus cos inverse theta. That is pi minus cos inverse of 1 by 2. Next is sine inverse of minus theta. That is minus sine inverse theta. By using that formula, we can write it as minus sine inverse of 1 by 2. Then let's recall these values from the table. Tan inverse 1, for which angle tan is 1. So tan 1 means it is 45 degree. 45 degree means when you convert this one into radians, 45 into pi by 180. That means it will get as pi by 4. Tan inverse of tan pi by 4. Then this pi will come as it is minus cos inverse of 1 by 2. Cos inverse of 1 by 2 means here cos 1 by 2, that is for 60 degree. 60 degree means pi by 3. 60 into pi by 180, that means pi by 3. These calculations we will do mentally, so that you can save your time as well. The next is sine inverse 1 by 2, for which value sine is having 1 by 2, that is 30 degree. 30 degree when you convert into radians, it is pi by 6. So sine inverse of sine pi by 6. Now we have to use those formulas, that is tan inverse of tan theta, cos inverse of cos theta, sine inverse of sine theta. That means theta itself. That is equal to here tan inverse of tan pi by 4, that is pi by 4, plus this pi comes as it is, and here it will come as pi by 3, that is minus pi by 3, and here as minus pi by 6. Now only calculation left, 4, 3 and 6. The LCM is 12. When you take 12 as the LCM, 4 dividing and 4 and 12 when you divide, 3 will get. So that 3 you have to multiply here, 3 pi, plus here there is no denominator, that means 12 we have to multiply. 12 into pi minus here denominator is 3. 12 by 3 is 4. That 4 you have to multiply in the numerator, that is 4 pi, and here in the denominator it is 6. You have to divide with the 12, that is 2 will get, that is minus 2 pi. So 3 plus 12 15, 15 minus 4 is 11, 11 minus 2 is 9. So we will get us 9 pi by 12. Here you can cancel, there is 3 is common in both numerator and denominator. When you cancel it, you will get us 3 divided by 4. That is, we will get the final answer as 3 pi by 4. Next we shall discuss question number 12. Find the value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. As before, let's take the question, that is cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2 is equal to, here you can see both are positive. So cos inverse 1 by 2 plus sin inverse 2 sin inverse of 1 by 2 as it is we can write, because there is no negative signs, nothing to change. Then just to recall by using the table, that is for which angle the cos of a particular angle is 1 by 2. So that is, here it is 1 by 2 is coming, that is for 60 degree. 60 degree when you convert into radians, pi by 3. So cos inverse of cos pi by 3 plus 2 sin inverse of 1 by 2. For sin 1 by 2, sin inverse 1 by 2 means it is 30 degree. 30 degree when you convert into radians, 30 into pi by 180, that means pi by 6 will be coming. So these conversions in the first phase you may face little problem because of mental calculation. When you do it few questions, it will be practiced. Once again, for cos inverse 1 by 2 means you have to see cos value 1 by 2, that is for 60 degree. 60 degrees. We have to change these degrees into radians. So that means 60 into pi by 180. In the last class we have discussed. And 60 and 180 when you cancel, you will get 3. That is pi by 3 will be coming. And next for 1 by 2, sin inverse 1 by 2 is 30 degree here. 30 degree when you convert into radians, 30 into pi by 180. That is 30 and 180 when you cancel 6 times. So pi by 6 will be coming. Now it is a direct formula using here, that is cos inverse of cos theta, that is theta itself. Here pi by 3 will be coming. Here 2 is outside, that will be there. 2 into sin inverse of sin pi by 6, that is pi by 6. Here 3 and 6, when you cancel here 2 and 6 will be getting 3 in the denominator. So pi by 3 plus pi by 3 will be coming. I am not showing the calculation here because it is quite simple. 2 and 6 when you cancel, denominator will be getting 3. So pi by 3 first part, and here we will be getting pi by 3. Now we can take 3 LCM. So since the common LCM is there, 3 pi plus pi will be adding in the numerator. So 2 pi by 3. So 2 pi by 3 is the required answer. Next we shall discuss question number 13. That is a multiple choice question. If sin inverse x is equal to y, then we have to choose the correct one from these 4 options. First one is 0 less than or equal to y less than or equal to pi, that is closed interval 0 pi. Next is minus pi by 2 less than or equal to y less than or equal to pi by 2. Here also closed interval minus pi by 2 plus pi by 2 because equal to symbol is there. And here it is 0 less than y less than pi, that means open interval 0 comma pi. Here it is open interval minus pi by 2 pi by 2. Here y is the range. So range means the principal value branch here. So the principal value branch of or the range of sin inverse x that we have already discussed in the first part. The range of sin inverse x, that is between minus pi by 2 and pi by 2 both inclusive. So here you have to check this part comes under which category, A, B, C or D. It is quite clear, it is in the B part. B is minus pi by 2 less than or equal to y less than or equal to pi by 2, means closed interval minus pi by 2 pi by 2. So our answer is B. B is the correct answer. Next we shall discuss question number 14. This is the last question from exercise 2.1. This is also a multiple choice question. Tan inverse root 3 minus of sec inverse minus 2 is equal to, there are 4 options, pi, minus pi by 3, pi by 3 and 2 pi by 3. First of all we have to go for calculating the value of this one, then we have to choose which one is the correct answer. Let's write tan inverse root 3 minus sec inverse of minus 2. here when you check, here is root 3 positive sign, so nothing can be changed. And here there is a minus 2, so sec inverse of minus theta is pi minus sec inverse theta. That is what we have learned the formula, pi minus sec inverse theta. So when you change these values here, tan inverse, this root 3 we can change by using the table. For tan 60 degree we are getting root 3, so 60 degree we have to change into radians. When you change 60 into radians, we will be getting as pi by 3. So this root 3 will be coming as tan pi by 3 minus, here by using the formula we have to change because there is a negative sign here, so it will be coming as pi minus sec inverse 2. It is written here, pi minus sec inverse 2. That is tan inverse of tan theta, that is theta itself, will be coming as pi by 3 minus, when you remove the bracket, minus pi will be coming, minus into minus plus sec inverse 2. This sec inverse inside the bracket 2 we can change. So here sec 60 is 2. Sec 60 is 2. Again we have to change 60 into radians, will be coming as pi by 3. So sec pi by 3 will be coming instead of these 2. Next, pi by 3 minus pi. These two will be coming as it is. Sec inverse of theta is theta itself, that is pi by 3. Next, we'll go for taking common LCM 3. Here denominator is 3, same as our denominator, so numerator will be coming as it is pi. Here there is no denominator, so multiply the denominator here. This denominator you have to multiply into numerator. So 3 into pi, that is 3 pi. Here also denominator is same with our denominator, so nothing to multiply. So plus pi. Pi minus 3 pi plus pi will be getting as minus pi, because pi plus pi is 2 pi. 2 minus 3 pi is 2 pi minus 3 pi is minus pi. So minus pi by 3 is our answer. So let's check where is minus pi by 3. It is here in the option B. So option B is the correct one. Next we shall discuss some more properties of inverse trigonometric functions. These are also a set of formulas, and here we are learning the formulas part by part, so make sure that you have learned properly. Here tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy, provided xy is less than 1. You have to calculate xy, or you have to check xy is less than 1 or not, then only we can use this formula. Next, again tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y by 1 minus xy, provided xy is greater than 1. In the previous case, xy is less than 1, and if xy is greater than 1, just the same formula, only just add a pi there. Next is tan inverse x minus tan inverse y, that is equal to tan inverse x minus y by 1 plus xy. So x minus y by 1 plus xy, provided x comma y greater than minus 1. So these are the three formulas regarding tan inverse x plus tan inverse y and tan inverse x minus tan inverse y. Next is 2 tan inverse x is equal to sin inverse 2x by 1 plus x square. Sin inverse 2x by 1 plus x square. Again same for 2 tan inverse x. In terms of cos there is a formula 1 minus x square by 1 plus x square. Next is 2 tan inverse x, again formula tan inverse 2x by 1 minus x square. So these are the three formulas for 2 tan inverse x. 2 tan inverse x is equal to sin inverse 2x by 1 plus x square, cos inverse 1 minus x square by 1 plus x square, then tan inverse 2x by 1 minus x square. So these 6 formulas you need to by heart for solving the next part or the next exercise few questions. Let's recall some formulas which we have learned in class 11. That is double of x and triple of x formulas. Cos 2x, there are 4 formulas: cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, 1 minus tan square x by 1 plus tan square x. Then sin 2x is 2 cos x sin x and 2 tan x by 1 plus tan square x. Tan 2x, 2 tan x by 1 minus tan square x. And 3x formulas, triple of x formulas, there is sin 3x is 3 sin x minus 4 sin cube x, cos 3x is 4 cos cube x minus 3 cos x, Tan 3x is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So this, especially these 3x formulas, that is very useful for calculating inverse trigonometric questions. So please make sure that these formulas are by-hearted properly. Next we shall discuss problems from exercise 2.2. First question, prove that 3 sin inverse x is equal to sin inverse of 3x minus 4x cube. Here, for proving this statement, what we have to do is we have to go to the right side first. And the right side we have to make it in the format sin inverse of sin theta. This entire term we have to change into sin theta format. Then we can use the formula sin inverse of sin theta. That is what our aim. So here 3x minus 4x cube. This is somewhat similar to our formula 3 sin x minus 4 sin cube x. That means if you replace x with sin, we can use this formula 3 sin x minus 4 sin cube x, that is sin 3x. So our first aim is to change this x. For that, RHS is equal to sin inverse of 3x minus 4x cube we have to take, and we have to assume x as sin theta. How we have taken x as sin theta in the sense, because we are familiar with this term 3x minus 4x cube means 3 sin x minus 4 sin cube x. When you see this term, you should remember this formula, means you must be very clear about the formula, then only at a stretch you will be able to go for assumption. Then from here theta we can calculate. Theta is equal to sin inverse x. Just to take this sign to the left side, sin inverse x is theta. This can be used at the end. So let's continue. Sin inverse, here instead of x we are putting as sin theta. So 3 sin theta minus 4 sin cube theta. Here it is clear, 3 sin x minus 4 sin cube x is sin 3x. So here will be coming as sin inverse of sin 3 theta. You can see here sin inverse of sin. Sin inverse of sin theta is theta itself, means 3 theta will be coming. That is equal to 3 theta we have written. Formula used is sin inverse of sin x is x. Now theta we can substitute. We have already calculated and kept here the value of theta. That is equal to 3 sin inverse x. This is our left hand side. That is equal to LHS. Hence the proof. Next we shall discuss question number 2. Prove that 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. And just like the previous question, on the right hand side we have to make it in the form cos inverse of cos theta. That means this one we have to connect with cos of something. It is quite familiar here. This is in the form 4 cos cube theta minus 3 cos theta. That means cos 3 theta formula. So let's take, that means we have to replace x as cos theta. So let's go for the calculation. Once you see this statement itself, the formula should come to your mind. So right hand side we have to take, that is cos inverse of 4x cube minus 3x. We have got the formula, that is cos 3x is equal to 4 cos cube x minus 3 cos x. And here instead of x, cos x is there. So our substitution is x is equal to cos theta. As before, let's calculate theta also. We can use it at the end. Take cos to the left, that means cos inverse x. Cos inverse x is equal to theta. So right hand side is equal to cos inverse of, when you replace x with the cos theta, will be coming as cos theta the whole cube minus 3 cos theta, or else directly we can write this term. It's not a problem. This is not compulsory to write. So cos inverse of 4 cos cube theta minus 3 cos theta. 4 cos cube x minus 3 cos x we have already discussed, it is cos 3x. Means this will come as cos 3 theta. That is equal to cos inverse of cos 3 theta. Cos inverse of cos is, cos inverse of cos theta is theta itself. So here cos inverse of cos 3 theta is 3 theta. That is equal to that is equal to 3 theta, and here theta we have to substitute now. Theta we have calculated and kept here, that is cos inverse x. That is equal to 3 cos inverse x. 3 cos inverse x is our left hand side. That is equal to LHS, hence the proof. Next we shall discuss question number 3. Prove that tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Here, while seeing the question itself, formula should come to our mind. This is in the form tan inverse x plus tan inverse y. Here you can see this is x and this is y. X into y, that is 2 by 11 into 7 by 24. Of course, these are fractions. It is less than 1. So we will use the formula tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. So let's take the left hand side. Tan inverse 2 by 11 plus tan inverse 7 by 24 equal to tan inverse x plus y 2 by 11 plus 7 by 24 divided by 1 minus x into y, that is 2 by 11 into 7 by 24. Here there is 2 and 24, we can cancel and we will write as 12. Now normal calculation only. Let's take the LCM. Here 11 and 24 are there in the denominator. So 11 into 24 is the LCM. 24 into 2 plus 11 into 7 will be coming in the numerator. Divided by, here 11 and 12 is there in the denominator. So LCM is 11 into 12. When you multiply 11 into 12 with 1 will be coming as 11 into 12. Here denominator is same as our common denominator, nothing to multiply, only 7 as it is will be coming. That is equal to tan inverse. Here when you do the calculation, 48 plus 7 into 11 is 77 divided by 24 into 11 divided by 11 into 12. When we multiply, you will be getting as 132 minus 7 divided by denominator as it is we can keep. That is equal to tan inverse 48 plus 77 will be coming as 125 divided by denominator just to keep same because we can cancel at the end. 132 minus 7 is 125. Here also denominator just to keep as it is, 11 into 12. That is equal to tan inverse. Here numerator is a fraction, denominator is also fraction. So just to write the first numerator 125 by 24 into 11, division change into multiplication. Take the reciprocal of the denominator, that is 11 into 12 divided by 125. Then here 125 we can cancel, 11 we can cancel, 12 and 24 we can cancel, in the denominator will be coming 2. So here once again I tell you, 125 we can cancel, 11 and 11 we can cancel, 12 and 24 we can cancel and write 2 in the denominator. That means numerator is having only 1 and the denominator is having only 2. That will be getting as tan inverse 1 by 2. That is our right hand side. That is equal to RHS, hence the proof. Move on to the fourth question. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. And here when you see the left hand side, it is not in the form tan inverse x plus tan inverse y because there is a 2 here. 2 tan inverse 1 by 2 is there. So first of all, this one we have to change it and we have to write left hand side in the form tan inverse x plus tan inverse y. For that, first we have to go for simplifying this portion, that is 2 tan inverse 1 by 2. We have learned a formula 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. We have learned that formula 2 tan inverse is equal to tan inverse of 2x by 1 minus x square. So let's calculate by using this formula, that is tan inverse of 2x. Our x is 1 by 2. So 2 into 1 by 2 divided by 1 minus x square. 1 minus x square means 1 minus 1 by 2 the whole square. Little bit of calculation, tan inverse of these 2 can be cancelled, only 1 will be there in the numerator. 1 minus 1 by 2 the whole square is 1 by 4. That is equal to tan inverse 1 divided by 4. When you take LCM, 4 into 1, 4 minus 1, that is 3. 3 by 4 will be coming in the denominator. That is 1 by 3 by 4, means it's a reciprocal. That is tan inverse of, take the reciprocal of the denominator, that is 4 by 3. So 2 tan inverse 1 by 2 we have got as tan inverse 4 by 3. Now we can substitute that into here. 2 tan inverse 1 by 2 plus tan inverse 1 by 7, that is our original LHS, is equal to, replace this value by using this one, tan inverse 4 by 3. And now it is in the form tan inverse x plus tan inverse y. Formula is x plus tan inverse x plus y by 1 minus xy. Let's do the calculation. This can be replaced by tan inverse 4 by 3 plus tan inverse 1 by 7 as it is. Use this formula, tan inverse of x plus y by 1 minus xy. That is equal to tan inverse. Our x is 4 by 3 and our y is 1 by 7. So 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. As before, little bit of normal calculation, that is tan inverse of 7 into 3 is the LCM here in the numerator. 7 into 4 plus 3 into 1. It's written here. And here You can check 3 and 7 is in the denominator. So you can take 3 and 7. 3 into 7 as common denominator. It's written here 3 into 7. The same quantity we have to multiply with 1. You are quite familiar with taking LCM, so not much explanation here. So this term you have to multiply with 1, that is 7 into 3 minus numerator is having 4 into 1, that is 4. That is equal to tan inverse of, here 7 into 4 is 28, 3 into 1 is 3, divided by 7 into 3 is 21. Here 7 into 3 is 21 minus 4 divided by 21. That is equal to tan inverse of, here 28 plus 3 is 31. 31 by 21 divided by 21 minus 24 is 17. 17 by 21. That is equal to tan inverse of 31 by 21 into, we have done in the previous calculation also, denominator, this division we have to change it multiplication, and denominator reciprocal. 17 by 21 reciprocal is 21 by 17. Now 21 we can cancel. We'll be getting as tan inverse of 31 by 17. And here if you want to cancel, here itself we can cancel the common denominator and do the calculation in one step itself. It's not a problem. This much explanation is done for the people who are facing difficulty in calculation part. Those who know that calculation, here 7 into 3 we can cancel. Direct addition and multiplication we can do, and answer we can write it in the next step. No need to expand up to here. So that is our right hand side, hence the proof. Dear students, today we have completed problems from exercise 2.1 and also we have discussed first 4 problems from exercise 2.2. I request all the students to go through the inverse trigonometry formulas and solve these questions independently in a sheet of paper. While solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.